Here's a video with the copper on the stove, just showing you cooking the plate. Just a demonstration. Nothing's happening right now. I've just turned it on high, so I'll start it again when something starts happening. Okay, you can see something happening now. Areas start getting red. That's the cuprous oxide, Cu2O. And what happens is the cuprous oxide is attached to the copper. The copper oxide, or cupric oxide rather, is the black stuff that's growing now, and it's following the red. As the red grows on the copper, the black grows on the red. So the cuprous oxide's on the copper, and the cupric oxide's on the cuprous oxide. Well, that's a little demonstration of it starting. What happens now is we let it get completely black and sit for half an hour to get nice and thick. Once the cupric oxide, the black stuff is nice and thick, when we let it cool, it'll flake off easily. And then we'll have just the cuprous oxide underneath. Here I just want to show you that this is all being done in the kitchen on the stove. And the reason I'm doing it on the stove is because of this little guy here, the range hood with the fan, will suck any fumes out. So I'll just turn on the range hood and there we go. Now I'll leave it. Here it is on the stove after cooking for 30 minutes to get a nice and thick black cupric oxide layer. I then turned the stove off and let it cool until it was room temperature. While cooling, the copper and the cupric oxide both shrink, but at different rates. So as this sequence of snapshots shows, the cupric oxide flakes off. I then rinsed it under warm water and rubbed it gently to remove any more black cupric oxide that would come off, leaving just the copper coated with some cuprous oxide, the reddish stuff that we're after. Next, to complete the solar cell and take it outside and test. Here's the setup for testing the solar cells, or solar cell. Homemade solar cells inside the container, salt water in it. There's the solar cell there and the other electrode. And here's my meter. So I'll set it up and you can see what happens when I block the sun. Okay, the cell is in full sunlight. What you want to look at is the very bottom scale just above the green line. It's the 250 microamp scale. Right now it's hard to say since it's such a low scale. It's about 10 microamps. And now I'll just block it. There we go. Now the solar cell is blocked, so we're getting pretty much zero. And I'll unblock it again. I just took the solar cell apart. I noticed that at the bottom here of my copper electrode, there's this area here that looks like it's got a buildup of some corrosion or something from the salt. It started out gradually. It was clear like this originally, so there are some losses due to that, and I can see a little bit of it right here as well. So the longer you have it sitting in the salty water, the less performance you'll get.